In this video, we're going to go over the review for your work, power, and energy exam. We started this unit by discussing the idea of work. Work is only done by forces, and a force will do work if it is exerted parallel to the direction an object's moving. So you have to have a force, you have to have an object in motion, and the force and the motion have to be parallel to each other. If the force is perpendicular, for example a centripetal force, then that force does no work. Work causes a change in energy. It's very important to remember. When work is positive, the object will gain energy. If work is negative, the object will lose energy. Gaining energy is like speeding up. Losing energy means the object is slowing down. So we have three different ways we could figure out the work done. We could be multiplying a force by a distance. That's the basic definition. That makes sure that your distance and force are parallel to each other. We could use the change in energy, either the total energy or just the kinetic or just the potential, or we could use the power and the time. Remember, work is measured in joules, capital J, and that's just a Newton times a meter. The definition of power is the rate at which we do work. Rate is important. That means something over time, so the equation is power over time. The unit for power is the watt, which is just a joule per second. If you see a W and you're not sure whether that's indicating work or power, indicating watts, just check the context. If the W is behind a number, it's telling you watts. If it's in an equation, then it's telling you here's what work should be. So for example, on your review, page 16, look at question number 4 real quick. It tells you that a machine does 600 joules of work in lifting something. Remember, when you lift something, the force that you have to exert is the weight of that object. Make sure you convert it to newtons if you need to. So in part A, it's just asking us how much power is exerted. So just divide your work by your time and you would get 300 watts. Part B, it's asking you how high is the load lifted. Remember that work is force times displacement. Also remember that we got to find the weight. When we lift something, that's the force. So multiply by 10 and we get the weight to be 400 newtons. So solving the equation for distance, I would get work over that force. Subbing in my numbers, 600 joules divided by 400 newtons, means that I can lift this thing 1.5 meters high. The second thing that we learned about was energy. Energy is the ability to do work. Remember, work is what causes change in energy. So energy is kind of like stored work. Two kinds of energy. One is kinetic, symbol's K, that's energy through motion. Equations K equals 1/2 mv squared. Things are moving, they can cause other things to move if they run into them, therefore they have kinetic energy. Second kind is potential energy, which we symbolize with the symbol U. That's energy through position. Equation for gravitational potential energy is just equal to mass times g times the height. Remember that energy is conserved when there's no work done. That means that the total energy remains constant. The total simply means your kinetic energy plus your potential energy. If energy appears to be lost in a given situation, that means it's gone to heat, or a little bit to things like sound and light, but primarily to heat. So as another example, in your packet, page 16, question number 8, you're told that a bird flies at a specific speed and height, and then it dies down and it gives you a new height and a new speed and asks you how much energy did the bird lose to friction. So your first step is always to figure out how much energy you're dealing with. Figure out the total energy. So the bird has kinetic energy, 2 joules to be exact. It also has potential energy. It's got a height, so it would be 180 joules. So the total energy is 182 joules. That's how much energy the bird starts with. Now the bird should keep that same amount of energy. However, you're told that as it dives towards the ground, it loses some to friction. So I'm going to find out how much energy the bird has after it makes its dive. Just repeat the process. The new kinetic energy is 98 joules. The new potential energy is 40 joules. So when you add those together, the bird only has 138 joules of energy. It's supposed to have 182, so what's missing has gone into heat. We're missing 44 joules. This is the answer. This is the energy that went to heat. So if you're asked to figure out how much heat is created, you're just looking for the missing energy. Another example from page 17 in your packet. This is the last question, question number 10. It's asking you how fast a roller coaster is moving in a couple of different points along a frictionless track. Again, your first move is to figure out what the total energy is. So you've got potential energy, 50,000 joules to be exact. It also has kinetic energy, 500 joules. It's going pretty slow, but it's way up high. So find the total just by adding the kinetic and the potential, and you'd get 50,500 joules. Now because this track is frictionless, we're not losing any energy to heat, and so that number is going to stay the same the entire time. That's what it means to say that energy is conserved. So at the next point, which is actually point A, your energy is still 50,500 joules. Find your new potential energy. So you take the height that it gives you at the next point, and you would figure out that the new potential energy is 25,000 joules. The total has to add up to 50,500, so I subtract that to get my new kinetic energy. So my kinetic energy is 25,500 joules. Now that I have that, now I can solve my energy equation, kinetic energy equation, for the velocity. So we get that the velocity is the square root of 2k over m. So doing some substitution, make sure you use our new kinetic energy, not the old one. So as I go farther down the incline, I'm going to get more kinetic energy, so I'm going to speed up. Make sure you use the correct kinetic energy right there. And when you punch the buttons on your calculator, you'd get 14.3 meters per second. Point C would be the same as point A because they have the same height. So if the roller coaster is at a height of 10 meters, it's always going to be going 14.3 meters per second. At point B, the real point B, the potential energy is going to be 0. It's on the ground, so it won't have any potential energy. That means that your kinetic energy and your total energy are the same. Kinetic energy has to be 50,500 joules. I'm going to let you finish off the rest of that. As always, if you have any questions or things that aren't clear still, please come see me during tutorials, and hopefully we can get you straightened out.